So
No, okay, we can still do domain and range. Domain is,
negative infinity to or negative infinity to -2 union -2 to positive infinity.
okay, that works. And then the range,
The range is uh
it's just a single value. What's the only y value?
the only y value is 2.
Two.
Yeah, 'cause they can't stop at the hole, so yeah.
That's everything.
Yeah. All right. Mm, Going into what are the ones that let's skip ahead to like the bottom of it, which is the one that had the most questions on. 15 and 16, I believe, was the most confusing too.
Okay, so on 15, do you have to do the like the 5 or 6? Remember you got that like 6 boxes thing? Are you gonna be doing that on the
On the
test too?
answer key, she didn't do it, but a lot of people in my class did do it, so I don't think it. I think yeah, probably, but it's basically the same. It's basically I think I thought I remembered most of it, but I feel like we probably should go over number 15 and 16 because
Oh,
15 is the projectile motion
okay.
problem that we
Yeah.
did earlier on, and then 16 is
Yeah,
the
so
fencing problem.
you have to remember the formula here, which is that the position, the height is the initial position, which is depending on your notation, it's h0 plus v0t plus well, in your problems, it seems to always be a minus 16t squared.
Yeah, she said it depends if it's like on there if it says feet or like
Right.
or something like that.
It is. So this is the so this is the US. If it were I'm sorry, metric, it would be minus 4.9 t squared.
Got it.
Okay. So it's projected from the ground. So that means that H0 is 0. You're starting at ground level. And then the initial speed, 80, is V0. So it's 80t minus 16t squared, something like that. Now, is this a calculator or oh, no calculator says there. So whatever you write, you should be able to factor reasonably. You're setting this equal to 0.
You could take out -16, right? Because it could be negative.
It it
If you take
depends
out,
if you want to put that as the leading term, which is fine.
yeah, when you take out -16, it becomes t squared. But it
So you
comes,
actually take out a 16t from both.
oh yeah, because you can take out t, so it'd be
Yeah,
t plus 5.
t minus 5.
Oh yeah, because you're taking out the minus, so it becomes
Yeah. So there's your two solutions. Minus 16t equals 0, t minus 5 equals 0. So t equals 0, t equals 5.
so how long the ball was in the air would be 5 seconds then.
Yeah.
The difference of the x zeros. Okay, got it.
It seems substantially easier than what you were doing, in your tests.
I think I did for also math theory problems, but I realized that it's not on the review checklist that she put that stuff that will be on the test. So I don't think she's putting max revenue on the test, but there are fencing problem and projectile motion. So I think next we'll go over number 16, which is the fencing, the fencing problem.
Yeah. Okay. Let me know when you're ready for us to look at this one.
Yeah, I'm ready.
All right. So the the drawing's the critical thing here. So there's 6 parallel partitions. So right now there's, maybe I misunderstood what they're doing here. 1, 2, 3. Okay. 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so not to scale here. Let me pull these over. All right, so you can sort of use your imagination that these are all the same. Um, that's one way to draw it. The other way is to go vertical with it. Doesn't really matter how you draw it, but how do you think you would draw this?
Um, yeah, I almost shot here. I think I drew it like the first time you drew the horizontal with uh lines going down for the partition, lines going vertically for the partitions. Yeah, I think I'd draw like that.
Okay.
So then you
I'm
would,
sorry, it doesn't really matter, but do you want to go is this way okay? Or do you want me to go vertical?
we can go horizontal.
Okay, so kind of a thing here is to call each of these X
Got it. And
and this
then,
and
yeah,
this that's Y, or actually I'm sorry, the whole thing is X. Sorry, the whole thing is X, but each of these is Y, and that's the way to do it.
got it.
So we're trying to maximize the area. So the area is X, Y. Okay, but we have 200 feet.
So would it be 200 minus, like, in this case, 6y?
Well, you
The
actually got more than 6 Ys. You got 8 Ys
8 was,
and,
okay. So,
and 2 X's
um,
because you got the
okay.
top and the bottom.
Okay. So then you set the A equal to 200 and then
No,
the
no,
200 equal.
you solve one of these. You solve this equation for Y or X, probably Y, and you put that into the other equation. But you should divide each of these, so that's like 200 over 8 because you're doing this by hand, minus 2x over 8. So that's 25 minus 1/4 x. And so the area is x times
Oh, so then
25 minus,
you solve for an equation for one of the variables, then plug it
yes,
in the other one, and
yeah,
then do it.
that's right.
Got it.
So that's 25x minus 1/4 x squared. And it's a parabola again, so you know that if you find the vertex, which you can do using formulas, x equals minus b over 2a.
Got it. So then in this case, minus 3 minus 25 over 2 times 1. So it'd be negative 25 over negative 1/2.
Yeah, so minus 25 over 2 times minus 1/2. So it becomes 25. And so that's the x value. They want the maximum area, so you can either put that back into the equation. Yeah, you gotta put that back in. You don't have a calculator, so you gotta put that back in. 25 times 25 minus 1/4 times 25 squared. I mean, for me, you can use a calculator. You can do it by hand on the test if you want. 'How are you doing on this?
Um, I'll see what we can use the 468.75.
Okay,
So max
we want some units there. So feet
feet
squared.
squared. So that's the maximum areas.
Yep. So they do also want the value of y, which I guess I neglected. Y is 25 minus 1/4 times 25, which ends up being 18.75.
All right. So now I would like to go over these. All right. All right. We can actually let me do this first. So now I'd like to go over these questions, which she had us take a photo in class.
Okay.
Basically just Google questions.
All right,
And
downloading
video.
it now. Graph following, domain and range, position. All right. Do you want us to start with A, or do you have certain ones you want us to do?
Let's go ahead and start off with A.
All right. All right. So the way I like to graph um, is making tables. I always start with one that's less than. That's the way that they're supposed to be written. Less than one first. So X and Y basically for that one. You're starting at 5, and you just go down a couple of points here, like 5, 4, 3 for this one. And then you get your value of Y just by putting those into the function there. You also make a note that it's a filled in dot there because it's the less than or the equal to. So this is minus 13, minus 11, minus 9, something like that. You can go on further, but you don't have to. For the next one, number 2, greater than, you share the endpoint, but this time you make a note that it's not a filled in. And so you maybe go 6, 7, 8. You'll notice, unfortunately, because of the 5, you get a fraction here. Like 6 is a lot easier, 8's a lot easier. You might skip the odd ones, but you got to do the endpoint. So it's 5/2 plus 1, which is 7/2. It's 3.5 to help graph. 6 ends up being 4. 8 ends up being 9. Sorry, 8 ends up being 5. It ends up being 4.5. So you get kind of a sense of what the graph is doing, and then you just graph basically. Now the one on the left's kind of. I mean, I don't know why your teacher chose this one. It's kind of a tough one to graph, um, because it goes down so far. But I don't know. I guess you got to. But so let me, even if you sort of like try to scale this property properly, like 4, 5, negative 13 is so far down here, -4, -11. Yeah, it's just a problem. But you got to get the right sort of direction here that doesn't go through the origin. So I don't know, how accurate do you think your graphs need to be? Like, what do you think she's looking for?
Um, for that, I think I do actually have the size graph that she's gonna give us here. Um, it
It's
goes,
just
I think the scale that she's uses during the test as a standard 10 by 10.
all right. So you got a problem here. This one's already out of the graph.
She might
So,
give us like a little bit of bigger graph though, maybe a little bit.
right. Point is, you got to sort of make
Yeah,
it fit.
sometimes she does give us like not like the standard 10 by 10, but it might be like the origin is like on the left or something like that, according to what type of graph and like where it is on the graph.
So
She
basically, you're
probably
showing you're showing this thing going, it's something like this on the right. Scaled potentially better. The domain and range is going to be the hard one for these because, well, domain is actually not that bad. Domain comes from the actual um, piecewise notation. The range, though, comes from actually looking at the graph. So that's why the graph is so important.
Yeah.
For the domain here, you've got numbers less than or equal to 5, numbers greater than 5. So that includes everything. Like if you're ever unsure, you can do a number line. Okay, there's 5. It's everything to the left of it, everything to the right of it. If I can get that to stay, everything to the right. That's everything. Minus infinity to infinity. They want to use interval notation. So it's minus infinity to infinity for the domain. The range, though, is a little bit tougher. The range you're looking at, all right, what's my minimum y value? Well, it's whatever the y value is here, which is negative 13. And it's like, well, how far up does it go? Well, it goes up forever. This goes up forever. This hole is there's a value over here that fills in that hole, so you don't have to worry about that. So it goes to infinity.
Got it.
That's probably the most difficult one, um, in my opinion. The other ones are kind of more straightforward. Um, so should we go to B, or do you have some other ones picked out there that you want us to look at?
We can go to B.
Okay. So B is in factored form of a quadratic, which means that you first want to find the x-intercepts by setting the factors equal to 0. So x equals -2 and x equals -4. All right, so why is that important? It tells you where it crosses the x-axis. -2, +4. Does it open up or down?
It would open down.
Down. So we know it does this, something like that. We should find the vertex. We need to find the vertex. It's always the midpoint of these. Wait a second. I graphed this completely wrong.
So it
Sorry about that.
so you take the zeros. Once you subtract the zeros and divide them by two to get the
Y- Yeah, well, you find the midpoint, which is at -3, and you put that in for x.
sign.
I guess it's 1. Okay, so now you can tell me the domain and the range. Give that a try, please, because we did a bunch of these
Domain
graphing.
domain is from negative infinity to positive infinity.
Okay.
Range is from negative infinity to one, including one.
Okay. All right, so C is a absolute value equation. You'd really like to find the vertex of it,
So the
like where it
vertex would
starts.
be 3 comma 5.
Yep. So let's call that 3, 5. It opens up. I don't know. I'm emphasizing more the min and the max points. Your teacher may want you to do a little better job of figuring out the actual graph where it hits the x-axis, excuse me, y-axis and other things. But what is the domain and range of this?
Domain is from negative infinity to positive infinity. Range is from 5, including 5, to positive infinity.
Good. All right. So D is some sort of quadratic that opens up. You really only need the vertex, truthfully. Like you don't need the intercepts. So what would how would you find the vertex of this?
So that,
Did that in an
mm,
earlier problem.
mm, mm,
The projectile motion problem.
minus 6x. Would it be 1 comma negative 2?
Okay. That work. We know it opens up. So domain and range.
Domain and range. Domain is negative infinity to positive infinity,
Okay.
and range is from negative 2 to positive infinity.
Okay. Very good. All right. This one is a cubic. So you want to know where it hits the x-axis. So it hits the x-axis at -4 and 4, but at 4, it's a multiplicity of 2. You remember what that means as far as whether it touches or crosses?
Velocity 2 means that it bounces or touches. Yeah.
Yeah, this is going to touch. The negative tells you about the where whether it starts high or starts low. You've got to figure out where it starts basically, which of these arrows is it?
Negative.
It's degree 3,
Odd and negative.
negative leading
Uh,
coefficient.
so it starts, so it would start off positive and negative.
Yeah, so it's going to come down
Yeah,
cross,
yeah. Cross it, not touch
touch.
it.
There you go. So how about domain and range?
Domain is negative infinity to positive infinity, and the range is negative infinity to positive infinity.
Very good. Okay. Any questions on those?
No.
Okay, let's keep going here. Solve some quadratic. All right. This one you would like to factor if you can. I'm not saying you can. So you take the 2 times the -7, which is -14, and you decide if there's two numbers that multiply to -14 but odd to +4. If there are, you can factor. If there are not, you can use quadratic formula, or you can complete the square. But so I'm looking at -14. That's -1 and 14, 1 and -14, -2 and 7, 2 and -7. So not possible.
Yeah,
So you are going to have to use quadratic formula or complete the square. Which would you probably do?
complete the square.
Okay, so to complete the square here, first move that 7 over, and then I would tell you to factor out the 2 from both. So this becomes x plus 1 squared, because you divide that by 2. Do you remember what goes back in this first sort of position?
1 because
It
it's
is
1
1.
squared.
It is 1, yep.
And then you have to multiply it by the 2 and add it over the other side. So that would be 2x plus 1 squared equals 9.
Yep. So you're not done. You got to divide
You
by
have to
2
divide it
now.
by 2 on both sides.
Yeah, take a square root,
X
subtract
plus
1,
1 squared
maybe
equals
rationalize.
square root, square root, X plus 1, 3, plus 1. X equals minus 1 plus or minus root 3.
It's 9 divided by 2. You got to divide by 2. You can't take the square root of just the top. I mean, you're supposed to actually take the square root of the top and the bottom separately. So it is 3 over square root of 2, but then you're supposed to rationalize. I don't know how much of this you're supposed to do, but it ends up being 3 root 2 over 2, like that.
So then it's X equals minus 1 plus or minus 3 root 2 over 2. Got it.
So G is actually really similar. So why don't you try solving G? I think that teacher probably meant for you to do F using quadratic formula, but this is really similar to the one we just did because it's kind of already completed the square. So
Okay,
you want to give
so
this one a try?
yeah. I got X equals 2 plus or minus 1.
Okay, did you subtract 1 from both sides?
Yeah.
Did you then divide by 5?
Oh, I subtracted the one after dividing it by 5.
Okay, well, okay. But you can't do that because then it's I mean you're dividing that by 5 as well. So here's what I was hoping you would get it down to. 9/5.
Yeah, then you get 9/5 if you were to do
And
it.
then it's really similar to the previous one. So why
Then you
don't you
could,
try it from
okay, so X minus 2 squared was 9/5. Square root, square root, minus 2 equals. Okay, so would that be X equals 2 plus or minus root 3 over 5?
well, yeah, it's the same as last problem, correct? Like it's the square root of 9/5 is the square root of 9 over the square root of 5, which is 3 over the square root of 5, and then you're supposed to
Oh,
rationalize,
wait, that's where,
right?
yeah,
So it's 2 plus or minus ends up being 3
3 root
root 5 over 5.
Got it.
Okay. Let's look at H now. I snipped that already. I did. Okay. So this is a nonlinear system. Most of them are solved by substitution most of the time. So we're going to solve this first equation for y. Could you solve that for y for me, please?
All right. Yeah.
Could be something like 2x plus 1. Is that what you got?
Yeah, it'd be like,
All right, so now we're subtracting. We're going to substitute in the other equation. Make sure you put it in parentheses. That way you get that negative to both terms appropriately. Otherwise, you might get a problem that has no solution.
X plus 4x minus 2x minus 1 after taking out the parentheses equals 7x squared plus 2x minus 1 equals 7.
And now you should always try factoring first. Two numbers that multiply to -8 but add to +2.
Um, x minus, oh wait, multiplies to -8 adds to minus x minus 2x plus 4.
No, that does work. And then you set each of those equal to 0.
0, so x equals 2 and x equals -4.
Yeah. All right. Good job. Number 6. Or number letter I. Okay. You can, whenever you see 4 terms, you're often going to do grouping. So when you look at the first 2 terms, you can factor an x to the 4th out of both.
Yeah,
And then what you hope for is that you can use the same thing here for the next one.
we can just do x to the 4th times x squared minus 1 put minus 16 times x squared minus 1.
Yeah, good. And then you factor again or factor out again. Now these are actually both difference of squares.
Yeah, so this one's x squared squared minus 4 squared. Or, yeah, that one's x plus 1, x minus 1. So then x squared minus 4x squared plus 4 x plus 1 x minus 1.
Yep. Now my question to you is are you going to be asked to solve the ones where they're not real, or not?
Let's see, on the so on like the checklisting that she gave us, it says polynomial factor by grouping 1 real, 2 complex.
Yeah. So they do want you to do all of them.
Yeah, I think they want us to do all of them, yeah. So x equals x minus 2, 2, 1, minus 1, and then 2i. Oh yeah, plus or minus 2i. All right.
All right, got one more here. It's kind of like one of those ones we worked on earlier. Drawing's kind of the big thing here. Two ways you can draw it. There's this is the wall. You can think of the wall there. This is x and y and x, or you can think of the wall, on the top side. X, Y, and Y. They give you the same answer. It's just you got to kind of decide which one you want to do.
So there's a wall, x, and this one has a feet to enclose a rectangular area for their dog and nuggets run around in the backyard. He will use the brick wall as one side of the fence and the remaining three sides to enclose the maximum area. What is the maximum area? Okay. So 1,000.
So yeah, the area is X times Y, but you're either going to write 1,000 equals, depending on which one you use. It's either 2x plus 1y or x plus 2y. It
So
doesn't really matter. You just pick the one
1,000 equals, let's do 2x times
plus y.
y.
When you solve
Y.
that for y, it's 1,000 minus 2x, and that goes into this equation for area. It's x times 1,000 minus 2x, which is 1,000x minus 2x squared. And then you're looking for the vertex. So that
Right,
ends up
so
being
vertex is
minus,
negative b over 2a, so
yeah. And
negative
then
1,000
then you find your y value by putting that back in
over
to
negative 1,001.
1,000 minus 2 times 250 is 500. And so your area ends up being x times y, which is 250 times 500 feet squared. Okay.
Times 500.